Today I'm going to talk about the current model of the atom as well as how we use quantum numbers to figure out where an electron is likely to be located inside of an atom. So the previous model of the atom was the Bohr model. And if you remember, the Bohr model had a nucleus and then it had various rings, various rings around the nucleus. If you remember, there was 2 electrons on the first ring, and then there was 8 on every one after that. So basically, they orbited around the nucleus like planets in a solar system. Today, we still agree that electrons live in energy levels. However, they don't make these perfect circles. They really don't behave like a solar system at all. So what these images are what the orbitals really look like. So rather than perfect circles, you get these funky shapes. So electrons are zipping around in this shape, they're zipping around in this shape, depending on how much energy they hold. So rather than just getting farther and farther from the nucleus, if they have more energy, they end up in kind of funkier and funkier shapes. So you're not going to have to memorize any of these shapes or anything. You just need to know that they don't make those perfect circles like Niels Bohr originally thought. And also, the current model is called the orbital model. So now we're going to talk about how the orbital model uses quantum numbers to estimate the location of electrons inside of an atom. So there's 4 quantum numbers. The first quantum number of an electron is the principal energy level. When you're saying what the principal energy level is, it's like saying the state of your address. So it's still pretty broad. It's really not giving you a whole lot of information, just a general idea of where you're located. So it'd be like saying that right now we're in the state of Ohio. If you want to go a little more detailed than that, the next thing you're probably going to tell somebody is the city. So if you're talking about electrons, the cities that electrons live in are the sublevels. Okay? So an electron lives in a principal energy level, and then you're going to say what sublevel it lives in. Okay, the next detail you can give somebody about your address is the street. So say we're on Fairmont. The next detail in an electron's address is the orbital. Okay, finally, the most specific thing that you can give somebody about your address is the actual building, or like the street number. For electrons, we call that the spin number. All the spin number is telling you exactly which electrons it is. Like, hey, there's 2 electrons in this general area, but the one I'm talking about is this one. Okay, we're not going to do too much with spin number, but just know that the 4th quantum number is a spin number. So we're going to look at these 3 in detail, one at a time. So starting with the principal energy level. I want to point out to you that levels and shells, those 2 words are going to be used interchangeably throughout your book, throughout lab, throughout my lectures. They really do mean the same thing. So anytime you see this principal energy, just know that it's talking about that first quantum number. So your principal energy level is going to be a number between 1 and 7. Now what that correlates with is the rows of the periodic table. So I will remind you what the periodic table looks like here. The periodic table, you can see, has 7 rows. So each row of the periodic table relates to a principal energy level. So these atoms only have electrons in the first principal energy level. These ones are going to have electrons in both the first and second principal energy levels. We'll get into that with the next screencast. So, principal energy level. We know what state our electrons live in. The next thing we want to know is the city, sublevels. So your sublevels are going to be letters, whoops, are going to be letters S, P, D, or F. Now, principal energy levels don't always have all four of these. How it's going to work, the number of sublevels is going to equal the number of your principal energy level. Okay, I forgot to point out here that the N commonly is symbolized for principal energy level, so you'll probably see that throughout lab. Okay, so the number of sublevels is going to equal the number that you had from the principal energy level. Now, it maxes out at 4. Okay, so this is a little confusing. I'm going to clarify it with a table that's in your notes that you're going to want to copy down. So if you are in principal energy level 1 or row 1 of the periodic table, that means you're only going to have one sublevel because these numbers have to match. So if you're in row 1, you have one sublevel, and that's going to be 1s. Okay, I wrote the letters on the previous page in a specific order, so if you only have one, you have to have an S. When we move down to the second row, there must be 2 sublevels available. So if there's 2 sublevels available, it's going to be 2s and 2p, because it was SPDF. So when you get down to the third horizontal row, the third principal energy level, now you're going to have 3 available, S, P, and D. So the pattern should be becoming clear here. S, P, D, and F. Now, the other rule I said is that it maxes out at 4. So after row 4 of the periodic table, all you're going to be doing is changing that first number because it maxes out. S, P, D, and F. And S, P, D, and F. Same thing for the last row of the periodic table. 7, S, P, D, and F. Okay, so it builds up to 4 and then it just keeps repeating. Noticing that these first number changes because that tells you what row you're in. So if you know you're in 4S, then you're in principal energy level 4 and the sublevel S. Okay, so these are again like getting more details of the address of the electron. Okay, so we know what state we're in, we know what city we're in. So if we want to know what street we're on, such as Fairmount, then we want to know where our orbital is for our electron. Now, just a general rule here, orbitals can house 2 electrons. Okay, so we're going to use that in calculations in class. I'm going to show you what I mean. So what this red guy represents is your S sublevel. And if you look at it, there's only one sphere here. There's only one shape here. So that means S has one orbital for electrons to live in. Because one orbital can hold 2 electrons, that's what we would write here. It can have a maximum of 2 electrons in it. Moving down to the p orbitals, the p subgroup. If you look here, there's 3 different shapes here. Well, they're just facing a different way, but there's 3 different orbitals. So you would write 3 orbitals. If each of those can hold 2 electrons, and we don't know where they are, they're just zipping around randomly. If each of these can hold 2 electrons, then these guys can hold a maximum of 6 electrons. Okay, let's slide down to the D sublevel. So the D sublevel has 1, 2, 3, 4, 5. It has 5 different orbitals. So if they each can hold 2, how many electrons can they hold? Total of 10, right? So we don't know where they're going to be, but somewhere in these shapes there would be 2 randomly positioned electrons. And last group. Our last group is the F group, and it has 3, 5. It has 7 orbitals. 7 orbitals that can hold 2 each for a maximum of 14 electrons. So they're hanging out in here, some random place. We can't really determine it because they're moving too fast. It's a good idea to memorize these values. Memorize that the S sublevel have 1 orbital, your P's have 3, D's have 5, and F has 7. That's going to be useful for you when we're doing the electron configurations in the next section of this chapter here. Okay, yep, so that's all the detail that I wanted to go into this one. I will talk to you in the next one.